Hello, and thank you for joining us. I am Jasmine Navarez, Digital Content Coordinator at Simulations Plus. I'll be hosting today's webinar behind the scenes, making sure we don't have any technical difficulties. In this webinar, Vice President of PBPK Product Development, Neil Miller, and Senior Director of Scientific Product Enablement, Becky Graves, will introduce you to the new features of GPX.2. A few housekeeping items before we begin. We take your privacy rights seriously by registering for and attending this event or participating in the Q&A session. You are allowing us to contact you for follow-up. You may ask questions via the questions panel on your dashboard at any time. If you need assistance, please use the hand raise icon. We'll address all the questions in the Q&A after the presentation. I'll hand it over to Tom, our Business Development Director, to introduce our speakers.
Thanks, Jasmine. Yes, I've got the privilege of introducing Neil and Becky. Starting with Neil. Neil's been at Simulations Plus since 2020 as our Vice President of PBPK Product Development. Neil started his career by studying at medicinal chemistry and drug metabolism at Loughborough University in the UK, before later joining GlaxoSmithKline, where he was based for over 20 years as a scientific director and PBPK team leader when he finished. Amongst his many activities at GSK, he supported projects such as predicting human doses to support candidate selection, and in drug product development with physiologically based biopharmaceutics modeling. Becky is one of our senior directors of scientific product enablement. She's studied applied biology at the University of Wales in Cardiff in the UK, before also joining GSK, where she worked for over 20 years in drug metabolism and pharmacokinetics. She then moved from running in vivo and in vitro studies to designing drug discovery strategies and involving PBPK models for first in human predictions, and then finally becoming a PBPK team leader herself. Becky joined Simulations Plus about 4.5 years ago, where she works on consulting projects and helping develop GPX before taking on a current position in June this year. I'd like to hand it over to them for the presentation. Thank you.
Prepare to be amazed by the latest version of GastroPlus GPX.2. I have suggested that, in my opinion, this is the biggest ever single release in the history of GastroPlus. And by the end of this webinar, you will be able to judge for yourself. I wish these scientific advancements, automation and incorporation of artificial intelligence had been available when I worked in pharma, as I would have been able to have done my modeling much faster and much better. On the menu for today is an overview of ACAT Plus, the distribution dashboard, intramuscular and subcutaneous dosing, PPSD, virtual replicate design, Assessments Plus, and Orchestrator. We also have a series of focused individual webinars following on from today that will go into the fine detail of all of these new functionalities. Please visit our website for details on these additional sessions. Back to today. Let's give you an overview of the new functionalities in GPX.2.
We will start with the advanced compartmental absorption and transit model. In GPX.2, your modeling of local drug disposition in the gastrointestinal tract will be much more mechanistic and ideal for targeting gastrointestinal related diseases or extended release. The ACAT model, as it is affectionately known, is the heart of the GastroPlus PBPK PBBM software, and with GPX.2, the heart beats so much stronger. ACAT Plus extends the verified and established ACAT model to include local drug disposition in the gastrointestinal tract. Put simply, this means more compartments, more layers, and more mechanisms. The 9 compartments in the ACAT model in the diagram on the left are extended to 13 in ACAT Plus, with the addition of the transverse colon, descending colon, sigmoid colon, and rectum. It is available for human, dog, rat, and mouse. All 13 compartments now have a mucus layer and gut tissue layers of mucosa, submucosa, and muscularis propria, in addition to the enterocyte layer. There is a mass transport model in the mucus layer with 20 sublayers and it includes generation of new mucus from goblet cells in gut epithelium, shedding of the mucus from the top sublayer, and the diffusion process. The mass transport model in mucosa, submucosa, and muscularis propria follows the same mechanisms as the classic ACAT model. Moving on from ACAT plus and absorption to distribution, one of the most important components of a PBPK model are the KP values, the tissue to plasma partition coefficients, which are based on tissue physiology. All tissues have a different tissue composition. If we look at adipose, on the left, it is 18% water and 79% neutral lipids, whereas liver, on the right, is 75% water and 3.5% neutral lipids. So how can a linear KP scalar be physiologically relevant? The distribution dashboard offers a way to physiologically modify KP values that accounts for differences in the composition of individual tissues. The plot clearly shows what is driving the KP in each individual tissue, and this level of fine detail is not available in any other commercially available PBPK, PBBM platform. For this compound, neutral lipids and neutral phospholipids, shown in green, drive the binding in adipose, whereas acidic phospholipids, shown in cyan, are driving the KP in the liver. The distribution dashboard takes established KP equations, such as the Lukachova KP equation shown here, and shines a light on what binding is driving the KP. We have taken the approach to add modifiers to the compound inputs for this and other KP equations. On the slide, we have highlighted the 5 terms in the equation using the color scheme from the distribution dashboard shown on the previous slide. For example, binding to acidic phospholipids is in cyan, and binding to neutral lipids and phospholipids is in green. If you have the observed volume of distribution, then you simply enter that in GPX.2 as step 1. And step 2 is that you click on the button to find the most appropriate physiological modification for your compound. Each modifier is tested independently within physiologically valid ranges. The one that best minimizes the error between predicted and observed volume of distribution while minimizing deviation from the baseline parameter value is selected and applied. Only one modifier, the most appropriate for the compound being modeled, is visibly updated per fitting operation, even though all are tested in the background. Alternatively, the user could choose to manually adjust the modifiers instead of using the automated optimization. We are gradually moving the additional dosage routes to GPX and have started with subcutaneous and intramuscular dosing. All other dosage routes are still available in Legacy GastroPlus and will be incorporated in future versions. Here we have an example for intramuscular dosing with the formulation on the left-hand side and the physiology on the right-hand side. In the screenshot for subcutaneous dosing, again, we have the formulation on the left and the physiology on the right. As per the ACAT and PBPK models in GPX, if you click on a specific tissue, in this case the abdomen, then you get the relevant compound and physiology details displayed for that tissue. The bread and butter of PBBM modeling today is PPSD modeling. That is where the fitting of dissolution data using a product particle size distribution gives a representation of the surface area of drug substance available for dissolution. GPX.2 contains the PPSD module, which was designed, developed, and tested by Mr. PPSD himself, Xavier Pepin. Type PPSD fitting into Google, and Xavier's name will be the first one that comes up. This module uses observed in vitro dissolution release data entered for specific drug product batches in the observed data view as the inputs for the PPSD runs and outputs a PPSD for use in your PBBM simulations. Put simply, the module provides for a quick, streamlined process of fitting and validation of the PPSD. Here we see the PPSD listed in the modules pane. It is composed of 3 panels: surfactants, inputs, and runs. Within runs, you first fit a PPSD and then validate the PPSD using all the available data. Next is virtual replicate design. This is an example of new functionality rolling out thanks to the feedback you provide. GPX.2 includes full and semi-replicate designs commonly used in bioequivalence trials, such as the 2x4x2 and the 3x3x2 designs. The 2x4x2 design, RT-RT, TR-TR, allows for the estimation of intra-subject variability of the test and reference by replicating the administration of test and reference formulations. The 3x3x2 design of RTR, RRT, TRR allows for the estimation of intra-subject variability of the reference products since the test product is not replicated. It is worth noting that due to this new functionality, all population runs will need to be recreated if you open a GPX.1 project in GPX.2. Next, we move on to Assessments Plus. This is like having an entire team of world-class PBPK or PBBM scientists sitting next to you and coaching you through your own model building. The embedded expert knowledge, based on hundreds of years of collected expertise and experience from multiple scientists, is then enhanced with our finely tuned large language model, which means your modeling journey just got a whole lot smoother and faster. Compound assessment kickstarts your modeling by providing advice from the get-go. With the click of a button, you will get compound classification and advice on absorption, distribution, metabolism, and excretion. This approach identifies gaps and major sensitivities, enabling a timely definition of essential experiments and prioritization of fit-for-purpose resources to support model development and preclinical verification. This is according to a publication cited over 100 times in the last few years, and now it is available to you with the click of a button. Simulation assessment, with its multiple modes, turbocharges your modeling by providing technical advice up to and including helping you improve the fit to your observed data. No stone is left unturned for experienced modelers, and for new users, this provides on-the-job training in the multiple disciplines that underpin PBPK and PBBM modeling. So every modeler wins, and the resulting modeling can be used to drive faster times to market for drugs. As for compound assessment, all this with just the click of a button. Here we see a simulation assessment with the mode set to improve fit to observed data. Other modes are descriptive analysis and drug product improvement, which has development stages of lead selection, preclinical, clinical, generic BE, and generic 505B2. For each mode, there is a description below to inform the user. The traffic light coloring emphasizes any issues Here we see that the area under the curve is under predicted, and by how much. But the game changer is that out of all of the multiple mechanisms and multiple parameters that drive oral absorption, it is the fraction absorbed, and specifically the permeability, that is swiftly identified as the root cause of the poor prediction. Based on the advice from Assessments Plus, if you fit the permeability via an optimization run, then your simulation is more than adequate. The pearls of wisdom from GastroPlus can be taken to another level with our finely tuned LLM. It is very important to note that Assessments Plus AI is an additional optional step, and the program does not take the feedback there automatically. You, as the user, are in full control of whether you want to have the feedback from Assessments Plus processed through the LLM and generate a report. We are all excited about the possibilities of artificial intelligence, but we know how critical it is for the AI we use to be validated to ensure reliability. AI only enhances efficiency if you're able to avoid hallucinations and misleading guidance. The AI advice in Assessments Plus AI is based on the embedded knowledge from GastroPlus, with the LLM being finely tuned by our scientists who know the science and understand your workflows. Assessments Plus AI gives you an in-depth summary of your simulation and organizes the advice from GastroPlus with the option to generate a report. But the jewel in the crown is the AI recommendations, which includes the opportunity to use the chatbot to help you further understand and implement the advice. Assessments Plus AI is actually one of 3 AI-powered tools that support robust modeling, as our GastroPlus GPT also includes GastroPlus Chat and Data Extractor. Both of these are included with the base GastroPlus. GastroPlus Chat is our new chatbot that can answer your questions in real time and help you overcome technical and operational challenges faster. GastroPlus Chat can be used for any GastroPlus related question. Data Extractor is a new tool that allows you to extract details and build data sets from documents such as PDFs. Orchestrator is the brand new functionality in GastroPlus, which allows automation of many of the tasks and workflows associated with the functionality described in this webinar. Orchestrator makes you the conductor. And just like the conductor of a musical orchestra, you will have the power to set the tempo, phrasing, and harmony of your modeling, which in this case means streamlining, automating, and scaling your GastroPlus workflows. Because the functionality is so vast, we are presenting a separate upcoming webinar about Orchestrator. But here is a taste of what functionalities it offers in GPX.2. You can see that you will be able to automatically create, modify, run, as well as extend the plotting functionality of GastroPlus, all without needing to be an R or Python expert, as we've built dedicated R and Python packages to make automation accessible to everyone from day one. Let me briefly explain how automation in GPX works. You cannot directly connect, or should I say talk, to the GPX engine. So you have to connect via an intermediate controller called the GPX service, also known as the REST API. Using the REST API, you can then control the GPX engine via programming languages such as R or Python. Let me excite you with one example. Ask any PBPK or PBBM modeler to name the most painful point in getting started with their modeling, and most will say it is the loading of observed data. Fear no more with GPX.2, as you can avoid the pain and save the time by doing this automatically with Orchestrator. Here, we are only showing one profile being loaded into GPX via an R script, but importing multiple observed data groups is possible. As a side note, other modelers may say that adding assets is a time-consuming process. Well, don't forget that in GPX.1, you already have time savers like asset templates that let you add the components you need with a single click. And here's the real win. Once your assets are created, Orchestrator makes them consistently reusable. Whether you're a power user or just getting started, Orchestrator helps you focus on the science, not the setup. As I mentioned, please join our upcoming webinar to see how this new world of automation will change your modeling workflow. That completes the overview of the new functionality in GPX.2. Do you now agree with me that this is the biggest ever single release in the history of GastroPlus?
So I think before we go into questions, we do have a little bit more that Becky can share and Neil can share on some of those other features that kind of follow on from that poll and some of those top features. So I will hand them back to them and then come back online a little bit more for some of the questions as well.
Thank you, Tom. So I think, Becky, should we start with the documentation? Because we haven't really spoken about that, have we? About how that's now going to be dynamically available for users. And I think launched today, if I remember correctly.
That's right, Neil. Yeah, hopefully it is launched today. So if I just share my screen, I might be able to show you where you can see these. So in the 10.2 interface, you'll see an option on the left-hand navigation pane. Right at the bottom is help. When you click on that, it takes you to the help view. And then you can click this button, which should enable you to view the documentation. This is what it looks like. And as you can see, we have several different sections available to you. We have the release notes, the getting started documentation, a section for the GastroPlus GPT tools, which includes GastroPlus Chat, Assessment Plus AI, and Data Extractor. In the GastroPlus user guide, you can see sections for each of the core functionality, the optional modules, and the additional dosage routes. And this is information about all of the views and input boxes in the software. If you move through to the scientific principles guide, this covers all of the science behind the mechanisms and the features included in the software, as well as all the equations. But in addition to the scientific principles guide, we've pulled out the equations into an equations guide. I think that was at the request of one of the regulatory agencies. So if you just need the equations, you have that in a standalone document now. The final section is the tutorial section. And here you can see step-by-step instructions to be used with the projects that we provide within the installation that will help you get to grips with any of the features or the new functionality, as well as all of the existing functionality from 10.1. So as you can see, it takes you through with instructions and screenshots, and hopefully will be a really good way to learn about all of the functionality that exists within GastroPlus. Because it's now online, we don't have to wait for a new release of the software to update anything, and so we can do it in real time. So please feel free to share your feedback with us, and if there's something that you feel is missing, or if there's something that you wish us to expand upon further, let us know, and we can try and get it into the documentation for you in real time. The final section of the documentation covers all of the Orchestrator functionality. So it really is your one-stop shop for all of the different help guides that you may need to use GPX.2. So thanks very much. And now I think if we hand over to Neil, he will take you through Assessments Plus.
Thank you very much, Becky. Let's make sure I share the correct screen. Can you confirm that you can see Assessments Plus? Or you can see the GPX?
I can, yep.
Thank you. So I think this one was near the top of the poll, if not top of the poll. So we thought we'd show you this one, and I'll give you a brief glimpse of PPSD as well, because they're new modules, and then we'll answer the questions that are coming in. So first, I will show you the Assessments Plus, but I will weave in a little bit of the distribution dashboard. So if we look in our compounds view, at the compound that we have here, we would open up the octanol water panel, and we can see that we're working with a lipophilic molecule here, the log P of 2.7, so fairly lipophilic. We also want to know what the ionization class is of the compound. So if we open up the dissociation panel, we can see we're working with a lipophilic basic compound. So we're already thinking that this compound would be binding either to the neutral lipids and phospholipids, the neutral phospholipids, or the acidic phospholipids in the tissues. If we then go to the pharmacokinetics view, we can have a look at the blood to plasma ratio and see that's significantly greater than 1 minus the hematocrit, 1 minus the hematocrit being around about 0.55. So that will be driving potential binding into the acidic phospholipids. So if I now look into the PBPK plus, actually, I'm going to pop this panel out just to show you that functionality. I'm sure those folks that have used the first version of GPX would have used the functionality to pop out the panel, because then that allows you to make it full screen or move it onto another monitor. So as I move down in this panel, you'll be familiar, if you've used the first version of GPX, with the PBPK diagram. And then when we look at the table underneath, we have the table and the KPs. And this is as far as you normally go with a commercially available software program. You see the KP, you don't know what's driving the KP. So if we move further down, we now see the distribution dashboard. So if we refer back to the presentation and the differences between the adipose and the liver, we see them here in the distribution dashboard. So the adipose KP of 1.43 is being driven by the binding to the neutral lipids and phospholipids, whereas the liver is the acidic phospholipids. So that's the distribution dashboard. If we run the simulation, so if I go to the analysis and you run the simulation, we can have a look, and the prediction is pretty good, but not perfect. So if we wanted some advice on how we could improve this prediction, we would go to Assessments Plus. We would add an assessment. We then select our simulation and the mode. So here I'm looking for that help in terms of it fitting to the observed data. Specifically, I want the distribution assessed. But if the clearance is off, it will warn me that the clearance is off. But I want that advice focusing on the distribution. So the single click of a button runs the Assessments Plus and that embedded knowledge. So you're in the graphical user interface. There's no LLM, there's no AI. This is embedded expert knowledge in the platform. And if this is as far as you want to go, you don't have to go to Assessments Plus AI and leverage that LLM. It does give you more benefits. It gives you more plots that are created by default, and you can get a report, but you can do everything in the graphical user interface. And you can manage the multiple rows of pearls of wisdom that you get with this done button here. Once you've read the message, you can tidy this list up. But the traffic light system here is drawing me to the fact that we've got green here. So the AUC is okay, but the shape of the profile is not predicted particularly well. So if we look further down, it is going to dig deeper and not just look at every point. It will be looking at that terminal time point. Sometimes the terminal concentration is only just greater than the the lower limit of quantification. So it will be looking at that as well and seeing if it improves the fit. And here I think it says it does. But the advice is use the distribution dashboard, which comes as part of your PBPK Plus license, to improve the distribution modeling. But we do recognize that at certain points, the model is as good as it's going to get. So it may be that you've tried that, and at this point, then you'd have to be looking to do something else. So we'll go back into the main Gastro Plus. We'll go to the distribution dashboard, and the volume of distribution for this compound is 134.7. So we enter that volume of distribution here. You can see that the volume that we're getting from our PBPK model is 96.17. That's the value that's displayed here. This is independent. So when you're changing the modifiers and the volume is changing here, it's not actively going to change anything into the PBPK model until you decide that you're ready to make that change. So you can really explore different methods, different modifiers, and then once you've done that exploration, then you transfer that finding into your PBPK model. So as was said previously, the modifiers will be simultaneously fitted in the background, but it will return the one that's the most relevant to your compound. So it's the one that's going to predict the volume accurately and also have the smallest change from the baseline value. So if we click on Fit KP Modifiers, then we've got the match of the volume of distribution now by multiplying the input, the log P. Now, this isn't going to affect anything else. It won't affect the absorption scale factors for your oral absorption modeling in the ACAT model or ACAT plus. This is purely looking at the distribution. Above, the volume has not changed here yet because I haven't clicked on the Calculate Tissue KP button. So a small change in the log P, so I'm happy with that. I click on Calculate Tissue KP, and if we look here, the yellow marrow at the moment is 1.431, but it's 2.55 in the distribution dashboard. So if I click on Calculate Tissue KP, then the value is updated in the PBPK table and the volume now is matching. So of course, if we then go to the simulation and now rerun the simulation, we're hoping to get a better prediction. So let me open up and change this to the log scale. You can see we've got a much better prediction, as good as it gets for a PBPK model. And if we went back to Assessments Plus now and then reassessed things, you're now informed that you've got a good model. And I was doing some application testing this morning. I had 3 sets of PK data. When you looked at it, it looked pretty good, but I thought I'll run it through Assessments Plus, and it came back and said, yes, this is good. You don't need to make any improvements. So if you're in 2 minds, so whether you're a novice user or an experienced user, you might be thinking, is this good or not? You can get the advice from Assessments Plus that will give you the green light to move forward on the next part of your modeling journey for the compound that you're looking at. So that's a brief demo of Assessments Plus. I'm going to hand back over to Becky now to show you the PPSD module, and then we'll get into the Q&A. So over to you, Becky.
Thanks, Neil. Okay, so I will share my screen. And again, hopefully you can see GastroPlus. Neil, can you confirm you can see it?
Yes, I can see it. Thank you.
Okay, great. So in this project, we have everything we need to fit and then apply a product particle size distribution, which is the drug substance area available for dissolution in a drug product to the observed in vitro dissolution profiles. So if we go down the navigation bar, you can see in observed data, we have 1 in vitro dissolution release group for a single formulation. And we have dissolution data for each of the conditions shown in the profile name. All of them are overlaid on the graph to the right, and by hovering over the legend name, you can see which points apply to which of the profiles. We also have a compound, a dosing formulation, which is an oral tablet, and a dosing schedule, which tells us how we're going to use that formulation. We have a human physiology, and we have the corresponding pharmacokinetic parameters for this compound and physiology pair. You can see that we're using a compartmental model for this example. We also have a physiology schedule and a simulation that pulls all of those assets together. So we can now move to the additional modules pane on the right-hand side and launch PPSD. So you can see that, as Neil already showed, we have 3 panels in the PPSD. In the surfactants, we have a number of different surfactants where we've obtained the required input data from the literature. But if you wish to use a different surfactant, you can simply add your own and populate the information yourself. In the inputs panel, we use all of the different in vitro dissolution profiles and populate these based on what's available from the observed data panel. So you can see all of the inputs I showed you in the observed data have been placed into the PPSD, and we've linked the associated metadata, for example, the amount that was used in the dissolution experiment and the volume. The next step would be to update the details for each of those in vitro dissolution experiments. So as an example here, we are taking the pH 6.8 media with 0.2% SDS. So the medium is water. It does contain a surfactant. You can select the surfactant from the drop-down list and then fill in additional parameters such as the critical micelle concentration and the micelle radius. There are also input boxes, concentration of the surfactant and the affinity constant. In addition, you can state what percentage of the target was reached with this particular formulation, any disintegration time and any degradation rate. The final piece of information you need to fill in is the aqueous surface solubility, and then the apparent solubility and the fraction unbound are populated. Once you've filled out the details for each of your input media, you can scroll back to the inputs table and calculate the sink values. This then populates the predicted maximum dissolved in each of the dissolution experiments, the sink value, and uses those two pieces of information to recommend which of your dissolution series you should use for validation and which one should be used for optimization. With this knowledge, we can move to the runs. You can create a run for this formulation and populate it with the formulation that you want to use. In the fitting window, you select the name of the dissolution series that was recommended for use as optimization, and then you can just simply fit the profile. The user-defined prediction tolerance allows you to define the amount of error you are willing to accept. So you can see that the default is 10%. We would recommend that you start with this. The program will then define the radii and the mass fraction that it requires to fit the PPSD. Once you have an initial fitting, you can go back and decrease the user-defined prediction tolerance and refit the profiles. Once you are happy with this fit, move to the final step, which is the validation. If we use all of the remaining dissolution series, with the exception of the one used for optimization, we can ask the program to validate and really have a look at how well it fits. If you wish to then tweak the solution that the program found, it is easy to do that. So you can simply type into the box and then revalidate. And you can see that by increasing that in the smaller particle size bin, the pink line. So the pH 6.8 is slightly better fitted. Once you're happy with the fit, you can transfer the radii and the radii and the mass fraction, and the program will automatically create an observed data series under the particle size distribution data type. And the radii and the difference will then reflect what was fitted in the PPSD module. To use that particle size distribution for a simulation, first you need to link it to your formulation. So you return to the dosing view, into the formulation panel and the particle size and form subpanel. Select the tabulated input data and the correct group name and series name for the PSD that the program has just selected. You can then move to your simulation, check that you're using the right dose schedule that includes that formulation, and then simply run the simulation. And that's how easy it is to obtain a PPSD and then use it in a simulation within GPX. Okay, so with that, I'd like to hand back over to Neil and to Tom for the Q&A.
Thank you, Becky. So we got so excited about these new modules. We wanted to give you just a brief glimpse so you didn't have to wait to October for the specific webinars. So, but please do attend those because that will go into much more detail and take it a little bit slower than we have in those last two examples, just to kind of whet your appetite, as it were. So, Tom, I think we've got a lot of questions.
Yeah, I was going to say, so obviously we'll try and get through everything we can, and then we'll go from there. So starting with the first question, can the KP value be estimated by the ADMET predictor module as well, or only through GastroPlus X.2?
Yes, you can estimate that with ADMET Predictor as the standalone package, so you get the KPs there. You can also get the same predictions within GastroPlus if you do an ADMET Predictor import. So we've talked about templates, so you set your template up with a dosing schedule and a physiology schedule, then create your project with one click, and then bring the compound in, and it would give you the same predictions if you had chosen the Lukachova method, which is the one that's in ADMET Predictor. So yes, you can do an ADMET Predictor, but you can also get the same ones in GastroPlus if you do the compound import and do all of the predictions from structure. Obviously, you can then supplement that with your measured data for your lipophilicity, fraction unbounded plasma, blood to plasma ratio, if you want to update those KPs. But yes, you can do it in ADMET Predictor and GastroPlus.
Thank you, Neil. Is the AO chat box / assessments plus secure for confidential data?
So the chatbot doesn't retain and doesn't train on any of the information that's in there. So yes, the answer to that question. And if I kind of take it in terms of if in the context of Assessments Plus AI, let me just screen share again. Screen 3, that's that one there. And if I go to Assessments Plus, can you confirm you see my Assessments Plus?
Yes.
So at the bottom, you've got copy for Assessments Plus. So it's a multi-stage to make sure that you know that you're in control. So once you've run Assessments Plus, if you want to have that information organized by the LLM within Assessments Plus AI and simply generate a report without using the LLM, so you can not use the AI, but still use Assessments Plus AI to get a report. But if you have the LLM toggled on, then it would give you additional advice. But you are in control. So you copy for the Assessments Plus, then you would launch Assessments Plus, paste the JSON content in, and away you go. So it's a two-step process so that you know you're in control. And you can see the text that's actually used by Assessments Plus AI. But no, it doesn't retain or train.
Great, thank you for clarifying. Oh, sorry.
I've had a sneak preview at one of the other questions. Shall I answer that while I'm screen sharing?
Go for it.
Yeah, so one of the other questions is, do you take into account lysosomal partitioning? So if I go back to the distribution dashboard, I've now switched the method from Lukachova to Lukachova with lysosomes. And if you look down here, we've got the additional compartment now. So if I had the Poulon and teal, that would just be homogeneous tissue. So this would just be one color, this bar. But if you choose the Lukachova with lysosomes, you've got that lysosomal partitioning in here. I've reset the example. So if I put the volume back in, let's fit the modifier and have a look at what happens. So in fact, it's a smaller change from the baseline value. If you remember before, it's 1.111. Now it's 1.06. So for this lipophilic basic compound, great question. This is probably the more appropriate method. And it's a smaller modification. So yes, we do take that into account if you choose that specific method.
Great, well, it's worked out you had your screen sharing. Are the ACAT, TCAT, PCAT, etc. included in the newest version?
No, do you want me to answer that one, Becky? Oh, because I keep talking, I keep stealing the show.
It's fine, I can answer that one. So no, they're not. We do have plans to include them in future versions, but I'm afraid you will have to wait for those. So we do have 2 additional dosage routes, as Neil showed. So the subcutaneous and the intramuscular, and the others will come in future versions.
I hope the person that asked that question voted, because we have run a number via the GastroPlus user group, the subcommittee on functionality, and also ourselves. We did do a survey as well. So hopefully you voted there, because we really are looking to introduce the additional dosage routes that have the most impact on your work. So we are prioritizing those. So yeah, hopefully you voted.
We're still getting more questions coming in, so if we do run out of time, I'm sorry, I'm making my way down the list as we can. So the next question is, is Assessments Plus similar to the optimization module?
No, it's distinct. It uses, but it will help you in guiding you on what you need to optimize, but it's a distinct module. So you would run it on a simulation. It's looking, so you can get descriptive advice on the example I showed. It would give you advice on the parameter that needs to be fitted. Then you would have to go away and fit that. So if you had the optimization module, you would then set up a run. Depending on how things move and how useful you find Assessments Plus, we're already thinking about what could be in the next version. So potentially it might run a parameter sensitivity analysis for you. It might even run the optimization. But at the moment, it's a distinct module. So it's going to inform you on how you could best use that optimization module.
Right. What is the maximum number of particle size bins that can be fitted in the PPSD dissolution model embedded within the platform?
I think that the PPSD will try to fit with as few bins as possible. However, you can definitely use more than 2. I don't think that there is a upper limit on how many particle size distribution bins you can actually use, purely the speed of the resulting simulation. But again, Xavier will go into that in more detail in the upcoming PPSD webinar.
Well, on a related note then, which probably might come up in the next webinar, but maybe you can answer it or confirm that would be the case. How is the surfactant impact accounted for in the calculation for PPSD? Sorry.
So to be honest, I think that would be better coming from Xavier. I know that obviously the example I showed had 4 different dissolution series without surfactant plus 2 with surfactant. And if you fill out all your details, it will take that into account. But for more of the specifics, Xavier is definitely your man.
Is there any way to batch upload multiple compounds and exposure scenarios, combinations, and potentially different combinations?
Sorry, Tom, just before we move to that one, can I just answer 2 more questions?
Yeah,
on
of course,
PPSD?
if you've seen them, they're relevant. Yeah, of course.
So PPSD is not included with the 10.2 license. It does need to be purchased separately. So we are hoping to increase the functionality and include other more PBBM focused mechanisms and tools within that license. So again, watch this space for further improvements, but it is a separate license. The other question was around how do you judge the goodness of fit? So if I just share my screen again, I can show you that when you do the validation, you get AAFE and AFEs for each of the different dissolution experiments. So you can see that the error ranges from kind of 2% up to maybe 6 or 7%. So that's how you would determine whether the goodness of fit was enough by considering the AAFE and the AFE for your dissolution series as a whole.
Thanks, Becky.
Just a word on those modules, actually. So, I mean, it's the way that we kind of operate. We don't want to force people to pay for something that they don't use. So looking at how much PPSD is used, that's why it's a separate module, because not everybody, we believe, would want that. But going forward, we are looking to rationalize the number of modules and licenses that we have. So for an example would be that if everyone that has PBPK plus and also has metabolism and transport, we could make it a lot simpler to have one license to cover both of them. So I know our business development colleagues are looking into how we can manage the number of modules, but still maintaining that desire that you configure GastroPlus for what you need it to do.
Thank you. It's also quite a few questions still on the PPSD modules. I think that's something we can also address with Xavier's presentation and also some of them offline as well. I'm just trying to move away from that just on the chance of giving other people to have their questions answered. Can you clarify the data extractor automatically extracts plasma concentration profiles from graphs in a PDF, for example?
Yes, so yeah, that data extractor, you would load in an image and then it would effectively digitize that image for you and give you the time concentration data to be able to be used in GastroPlus. And that's available with the base, as is the GastroPlus chat as well.
Great.
And we will cover that in the Assessments Plus kind of GastroPlus GPT webinar, which is, I think, now in November, if I remember correctly.
And then the other question, in the newest version, has the reporting of basic PK parameters such as the area under curve or the half-life from a generated CP time plot gotten easier? Is this something you can use the AI chatbot for example?
That's a good question, actually. So if, sorry, Becky, were you about to answer that?
So it's something that we're looking to do via Orchestrator. So hopefully soon it will become easier. But with the scripts currently released, I don't believe that is possible at the moment.
So we would welcome requests and suggestions for scripts. There is a little bit more functionality if you've used GPX in the analysis. So in the summary view, we added additional parameters in there, like clearance, for example. But of course, we're getting lots and lots of requests for parameters, and then that would make a lot of horizontal scrolling, which isn't the ethos of GastroPlus in the newer versions. So you can then, as Becky says, via Orchestrator, tailor that to what you want. Also, just with the Assessments Plus, I should have said that once you've loaded that information in, you can start having a dialogue with the chatbot about that assessment. So if you said, oh, what is the fraction absorbed for this assessment, it would then return on that. I will check it to see whether if I ask it the half-life, whether it will return the half-life. So thank you for that question. It's given me some more testing to do.
Great, thank you. And I think just in the interest of time, we have probably one more question. So which, in your view, do you think Assessments Plus is aimed at new users?
No, I think it's for everybody, and they'll remain nameless. But one of the people that were behind designing it, that was telling them, informing them on their modeling. I thought, no, and they were thinking it wasn't me, honest. And it was like, no, I haven't missed that, and they had. So even for an experienced user, there's so many components in a PBPK or PBBM model, and so many settings that you are possibly not going, no stone will be left unturned by using Assessments Plus for a more experienced user. So yes, you've been on the training courses, yes, you know everything, but in that moment, are you remembering everything that we've taught you? But because that is hard coded with that embedded knowledge, you won't miss anything. So I really think it's useful for experts as well, and I am using it and learning from it.
Great. Well, obviously, oh, sorry. Becky.
Sorry, Tom, just to finish, we better return to the question that I interrupted you on.
Oh, of course, sorry.
So, Neil, is there any way to batch upload multiple compounds and exposure scenario combinations, or potentially different combinations of ADME parameters in 10.2, either via the API or via the GUI?
So I would say yes, via the API. And also there is a lot you can do in the GUI as well if you kind of set up an ADMET predictor import and point it to certain parameters as well. And then I'm sure in the Orchestrator session that's coming up in the webinar in a few weeks' time, they'll also look at kind of high throughput pharmacokinetics, because I know they've been looking at that. So yes, you can do it in the GUI, but yes, you can do it with the API as well.
No, thank you, Becky, for making sure I didn't miss that one. Honestly, thank you, Neil, Becky, for such a great webinar and obviously answering lots of questions. As I said, there's very many that we still haven't been able to get to, so we will get back to you. And I'll obviously hand over to Jasmine to conclude the webinar. Thank you, everyone.
Thanks, everyone. So again, for any questions that we're unable to answer, someone from our BD team will reach out to you with answers following the webinar. We want to invite you to visit our website to learn more about GastroPlus X.2 and other software platforms. I've put links in the chat if you also want to follow us on social media. This webinar has been recorded for playback and will be available on our website and YouTube channel. This concludes our webinar for today. Thank you, everyone.